Namaskar. Myself, Dr. Meenal Gupta, Assistant Professor in Chemistry from Government Arts and Science College, Ratlam, Madhya Pradesh. My video topic is aromaticity and related compounds. What is aromatic compounds? Aromatic compounds are those compounds which follow Huckel's aromaticity rule, that is 4n plus 2 pi electrons, where n is an integer number, maybe 0, 1, 2, 3, 4, so on, depends on the structure of the compound. Compounds are of two types. One is benzenoid compounds, another is non-benzenoid compounds. Benzenoid compounds possess benzene ring and non-benzenoid compounds may be 5-membered ring, 4-membered ring. It means they have not benzene ring. Generally, all aromatic compounds give substitution reaction easily. They are highly stable. They possess resonance and have high degree of resonance energy. They show ring current effect. If we take out NMR spectrum of that types of compound, then the NMR peak value obtained at greater than 6 ppm. It means they show ring current effect. So by use of NMR spectroscopy, if we have obtained value more than 6 ppm, then we can say compound is aromatic in nature. In general, benzene is aromatic compound, and all these are resonating structure of benzene. First three structures are Debar structures and last three are Kekulé structures. In Kekulé structures, in first when structures designed, then assumed that carbon-carbon double bond, if there is present, then it will be single, double. But if it is localized double bond, then the bond length between double bond and here carbon-carbon single bond will be not equal. But in observation showed that in each carbon-carbon bond length in benzene is equal bond length, and that is 1.39 angstrom. It means these bonds are not localized, they are delocalized, and they are delocalized means all pi electrons are delocalized on all 6 carbon atoms. It means each carbon having 1.5 bond character, neither the bond length of double bond and nor bond length between the carbon single bond. And the showing the reaction of here benzene shows nitration reaction, benzene shows acetylation reaction. It means here substitution reactions takes place here, and this we can represent as this delocalization of pi bond clouds. Here these two p atomic orbitals are overlapped, sidewise overlapping to make pi bond, but there is another possibility here, and therefore the whole possibility, it means this all pi electrons are delocalized on each carbon atoms. And like naphthalene having 2 benzene rings, condensed benzene rings, and having 5 pi bonds and 10 pi electrons. Here n equals to, we put 2, 4 into 2 plus 2, then 10 pi electrons present, and here also naphthalene shows resonating structure, resonance, and therefore it is also a stable compound. And if compound is like that unstable, then it will easily tend to tendency to stable one. So this one is dihydropyridine, and it will oxidize to the stable compound pyridine. Pyridine again non-benzenoid aromatic compound having 6 pi electrons in that ring, and it will be delocalized. And the classification of the compounds on basis of aromaticity, here this all are benzenoid compounds. This one may be benzene, phenol, heterocyclic compounds, pyridine, benzofuran, and here three atom ring containing cyclopropenyl cation having only 2 pi electrons, means 1 pi bond, but this here is plus charge, and this positive charge is delocalized on this all three carbon atoms. Here n equals to 0. This is cyclopentadiene ion. It is again aromatic compound. Here n equals to 1 and total 2, 4 and 6 pi electrons are present. This negative charge is delocalized on all each carbon atoms, and this is cycloheptatrienyl cation. It means troponium ion, and it is 7-membered ring, and this plus charge means this carbon is sp2 hybridized. Each carbon is sp2 hybridized. It is again aromatic compound. This plus charge is delocalized on each carbon atoms, and they are highly stable compounds. This one is azulene and this one is anulene. Anulene is 14 anulene, 14 anulene having 14 pi electrons, means 7 pi bonds, and anulenes means a large ring. Maybe say anulene means one ring containing compound, and only one ring may contain more than many pi bonds. It has very large one ring having this compound 14 anulene, and it is aromatic compound. Then this one is 10 anulene. Again it is one cyclic ring, but here internal hydrogen at the junction, it collapse to each other and interact to each other. Therefore this ring will be out of plane, and this compound is not aromatic. So further criteria of aromaticity, one is Huckel rule followed by the all compounds, but second one, the compound should be cyclic in nature, planar in nature, all pi bonds are delocalized in a plane, not out of ring. Therefore the compound may be said to be aromatic compounds. This is tropone. It is aromatic ketone compound, tropone. Here again 6 pi electron systems are present, and it is aromatic compound and having the carbonyl functionality present here. All these are resonating structures of the tropone. And this is pyridine. You well known about the pyridine. It is cyclic coplanar having 6 pi electron and having a nitrogen heteroatom in the ring, and it is a stable compound like is benzene. And this 5-membered ring containing heterocyclic compound, that is non-benzenoid aromatic compound. X is a heteroatom. X may be nitrogen, may be sulfur or oxygen, depends on the nature of the compound, may be pyrrole, thiophene or furan. And here one more interesting thing is that here heteroatom having a lone pair of electron, and this lone pair of electrons used in delocalization, used in resonance, and therefore the whole system having 6 pi electrons of the system, and therefore all compounds showing aromatic nature follow Huckel rules and highly stable and giving substitution reactions. And these all are aromatic ions like 3-membered cyclopropenyl cation, propene, cyclopropene, 3-membered, cyclopropene plus charge propenyl cation, cyclopentadiene ion, cycloheptatrienyl cations, and all three compounds are aromatic in nature. Here 2 pi electrons are present, here 6 pi electrons are present there, and here again 6 pi electrons are present, and all having each carbon atom is sp2 hybridized. Cyclopentadiene is as acidic as ethanol. Cyclopentadiene simple compound acidic होता है. Why? Because it liberates proton easily. Why it liberates proton easily? Because when it liberates proton easily to form cyclopentadiene ion, and this cyclopentadiene ion is more stable due to resonance, due to following Huckel rule, and highly stable. Therefore, it easily converts from cyclopentadiene to cyclopentadiene ion by liberation of proton in presence of either simple weak base. Therefore, it is showing acidic character. And salt of cyclopentadienyl cation are stable in water, and because 6 pi electrons in this cation, 6 pi electrons are present, and therefore it shows more stable than other form of this. So, thank you very much. Thank you.